Hi guys, let us discuss about lambda, map, filter and reduce functions. These are extensively used in Python program. So let me make a multi-line comment. So what is lambda? It is a keyword. Lambda is a keyword. But what is this? It is an unnamed function. We can also call it as anonymous function, right? That takes any number of arguments. No limitation on the number of arguments. But it should be written in one line. That is the condition. Okay. It should be written in one line. That means that is it should contain one statement. That's it. That is what it means. So let us take an example. Assuming that I make a lambda function will be typically it will be like this. So here x is an argument. Okay, and x plus is nothing but is a return statement written in one line. So the problem over here is how I will invoke this. It is a function. See, you are seeing function. It has created, but how to invoke it? Look, though it is an unnamed function, it is created in memory. If it is so, any location in the memory can be referred to by a name. So what I will do is I will say, okay, give it some name. I will say unnamed. I can give any name A, B, C. I have given unnamed. Now what I will do is I'll say unnamed 5. So what happens? It has taken 5. See what happened when I say unnamed. This lambda function got invoked. The 5 got passed to x, and this is the return statement. What return statement is there? X plus 1. So if I have given x 5, so x is 5 plus 1. That 6 has come back to me. That is how I stored. Right? See, this is doing exactly what it. If I had written something like this, suppose I'm writing func and I say return x plus 1. And if I invoke this function func 5, what is returning? 6. So this is a named function. It is already stored in memory. This is also stored in memory, but it doesn't have name. So I have created a variable referring to this particular object, and with that name indirectly I am invoking this. Now you may ask, if I can write like this, then why this complication? So the point is this, that there will be many scenarios you would think that why to store a function, let us do that functionality on the fly. So just don't store it. There is no need to store it. So what is the use case? Where exactly we use? So let us discuss about map. Map is a function. See, this is the signature. Map is a function which takes first argument as another function and second argument will be iterable. And this is a must. So first argument is a function. So I will write any function I can write. I will write my function which I created just now, and I will say take this iterable 1, 2, 3, 4. Okay. So once I enter, what will happen? It responds with this. It has created an iterator. Iterator is an object which is iterable, but whose contents cannot be seen unless and until I have iterated it. Okay, through some iterative process. So If I want to see the content of this iterator, I can convert into list. What is list? List is iterable. From this iterator, I have converted this and this is iterable. So 2, 3, 4, 5 actually it created, right? Because always when I'm passing to this function, it is returning 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4, so on, so forth. So it has created this. Now, should I be converting into only list? Well, I could have converted into even tuple. That is my choice, right? If I want to see what is contained in that container, I have to have an iterable which will show me contents. So 2, 3, 4, 5. Very good. Now you will say next point, function, what it is doing? It is just taking a variable and adding one and returning. And for that, I have to write a function and store that. Why can't I do this on the fly? Okay, if that is the idea, all that you do is replace function with lambda. Whatever you have written over here, don't write, you write in lambda. So what will be the format of lambda? Lambda x colon x plus 1. Done. So let me bring this here. Bring this here. I will say no. I don't want to use named function. I will use unnamed function, anonymous function. So you do write that lambda x, that is argument, and this is return statement. You don't write, you don't write return statement. That is not needed. That is meant that it is returning because it has only one. It is taking arguments, any number of arguments. I have given only one argument, and then it will have return statement. So whatever I written, that will be returned. Whatever I have written here, that will be returned. So now enter this same result. Here I have used lambda, here I use function. And why I am using lambda? Because I don't want to store, and I can always write lambda x colon x plus 1. Not a big deal. For that, why I should write function? That is the idea behind having a lambda function. Do simple things on the fly rather than store it in create an object function, store it and use it. You may also say, listen, I don't want to write this. This is too big. So what I can do is, okay, this itself you store somewhere, maybe A1, something like this. Okay. And then rather than writing lambda, you write A1. Same thing again. So I will not write it. This becomes big. So for that time you are saving, just say A1. Same result. Okay. So that is what map is doing. Map is making use of lambda to give you. So let us, having understood what lambda is, now focus on map. See what map is doing. Map takes a function, it takes an iterable. From iterable, it takes one element, passes on to the function. Then function returns something that it accumulates. So here what is happening? It has taken one from iterable, passed on to this lambda function or this func or whatever, and it has returned 1 plus 1. So it has captured 2. Then it has given 2 and given to this function, it has returned it what? 2 plus 1. It has taken 3. Then it will take 3, the same treatment, then 4, same treatment. So what will happen? 1, 2, 3 will become 2, 3, 4. So this is the end result of your map function. It returns iterator. I converted this to list. So that is what it is. I am using lambda function, an unnamed function, and doing this because it is very simple task. If the task becomes little complicated, suppose my function has got multiple lines, I cannot use lambda, then I will use some function. Say for example, I have a small function I'm writing, okay? I will say def sum digits. I will take some number and then I will say sum is equal to 0, and while n not equal to 0, then what you do, sum is equal to sum plus n modulus 10, and then I will say n is equal to n double slash 10, that is integer uh, divider, And then what it will give me? A point comes when it will get out of the loop. I will say return s. See, what is happening is a number comes 1, 2, 5. See what is happening when I do this operation. S is 0. So s will have, suppose I am taking number like this. This number I have passed 1, 2, 5. So first my remainder will be 5. S is 0. So the value of s is 5. And here what I am doing, this gives me 12. N becomes 12 now. From 120 it becomes 12. Again it goes back. Now 12's remainder is what? 2. So 5 and 2 will get summed up. It becomes 7. Now I am left with 1. Then 1 goes and it becomes 1 year. Again I will divide 1 slash slash 10. I will get 0. So I have already added 1 to 5 and it becomes 8. Right? So just check this function whether it is working well or not. I'll say 1, 2, 5. I'm expecting 8. Yes, 8. If I pass something like this, I'm expecting 2. Yeah. If I pass only 0, what will happen? Okay, 0. Now, I will, if I have to do, I have iterable and every number I'm passing to map and I'm expecting map to give me this result, right? The sum of all the digits. I cannot do this through Lambda because Lambda cannot handle so many lines, so much of logic, right? No. So what I will do is now let me bring this here, copy paste, and instead of A1, I will write some digits. And here I will write 125, 202, 333, 44, 44. So what happens now? Listen, map has created an iterator. 125 is 8, 202 is 4, 333 is 9, and 44 is 8. So basically, this much we will write. This much only we will write. This will create an iterator. To be able to see what is there in iterator, we are writing list command, right? We will write list command. That's it. I can write tuple also or whatever. Oh, not capital. That is typo. List. Right? So the point is, can I write lambda? No, I can't write. I have to write function. If there is something very simple, very trivial, write lambda. Done. Okay. Now see filter. Filter command, what it will do. See, I will bring the same thing over here. Okay. Not really this, not this function. Maybe I will have some other function. Okay, what is happening? I don't want line numbers. Okay. So here in the filter, and I will of course compare with map, right? So what is happening is, suppose I have 1, 2, 3, 4, 5, and I will write here again, I will write lambda function. Lambda, and I say take x, and I say colon x modulus 2 is equal to 0. Listen, what will happen? What this filter will do? It is very interesting, right? It has created an iterator. Convert this into list to be able to see what it has done. 2 and 4. What it is doing is it is taking every element and operating on this like this. And whichever element is getting evaluated as true, that element will be stored. All other elements will be rejected. So I am checking for, is x modulus 2 is 0? So for 1, the answer is false. Reject 1. Then 2 comes. For 2 modulus 2 is equal to 0, the answer is true. Okay, take 2. Again 3 comes, reject it. 4 comes, take it. 5 comes, reject it. So 2, 4 has come. What is interesting over here is only true will be captured. Now if I say instead of equal to, if I say not equal to, then what it will capture now? It will capture 135 because x modulus 2 not equal to 0. If 1 comes, for 1, yeah, it is evaluating to 2. Take 1. So it is evaluating to true. You take one. Now 2 comes. 2 modulo 2 not equal to 0. No, it is equal to 0. Not equal to 0 is false. So you reject false. So what will be rejected? 2 will be rejected. So now this time I will capture 135. Correct? So it all depends on your statement. This statement, if it is evaluating to true, whichever element is involved in giving you true will be the element that will be accumulated. All other elements will be rejected. So that is what filter is doing. Correct? Now you may ask, can I write map? What will happen to map? So map works very differently. Map will not filter. See, map's capacity is not there to filter. It will take each and every element. But the thing is that what is happening over here? See, which true or false. So one element comes, either it will be false or true. For one, it is true. The value will be true. True is captured, then false, then true, then false, then true. Now map is giving you true, false, true, false, true. Okay, map. Now if I will change the condition, if I write equal to true, equal to 0, x modulus 2 is equal to 0. So what will get evaluated to true now? Only 2 and 4. So I will have 2 trues and 3 false. So false, true, false, true, false. So just see this. This is how. So that is the difference between filter and map. Map will never filter your elements. It has to evaluate everything, and based on whatever is the return statement, this is return statement, that return statement it will capture. But filter will not capture return statement. This, it will only see if it is evaluating to true, then underneath element capture, all other elements simply reject. Now, having seen filter, now we are left with reduce. For reduce, what we will do? We will we will have to say func tools import reduce. Okay, this is the function that we will be using. Let us straight away use. What does it do? It says that give me a function. I have given function. Please give me 2 arguments. It says, okay, these 2 arguments I'm giving. So what I will do with those 2 arguments? I'm simply adding. What is my iterable? 1, 2, 3, 4, 5. Well, see what is reduce doing over here. It is basically, it is a function that implements mathematical technique called folding or reduction. Okay, it is a mathematical technique which either does folding or reduction. What is this folding or reduction? Let us see here. See what it does is it first takes 1 and 2 and then adds that. Okay, it has taken 1 and 2. X is 1, y is 2. It added. Okay, next it has taken 3, it has added. Then it has taken 4, added. Then it has taken 5, added, and then it will give you the result. So the result will be given to you. This is what it is doing. Correct? Now let us see what it's doing. It will give you one value, mind you. It is adding everything. It will give you one value, 15. So there is no question of iterator over here. All these numbers are getting evaluated to just one number. But there is another thing which can be done with reduce. Just bring it here. You can give some initial value, one initial value, whatever value. If I give 0, the same result. Suppose if I give initial value as 100. So what happens? Your initial value will be 100. For 100 to 100, you will add 1, then 2 and 3. So you will get 115. So that also you can do if the requirement is like this. Okay. If you want to have 0, rather you simply do, because it is optional thing. So see, it says function iterable. Okay. And then it says initial. What is that initial thing? So here I gave 100. So it becomes 110. So this is what is reduce. Reduce will give always a single value. Here also I'm using lambda. Correct? Now, you will say, can I use only summation? No, no. You can use multiplication. You do multiplication. So if I want to do multiplication, I will just simply reduce it, right? So what will happen now? Let me remove this 100 also. So what will happen? Okay, this is 12, 24. 24 should be the result. 24 has come. Now it is product. So same thing. Now this entire thing here, what happened? No. So instead of plus, now I will write what? Multiplication sign, correct? So it is doing what it is doing. Let me remove this 5. 5 is not there now. Okay. This is what it is doing. And you are getting result. You want to do subtraction? Why not? You do subtraction. Now what will happen when you do subtraction? Don't add. No, just see, keep subtracting and just see the result. What will be the result? Minus 8. Okay. I can also do division. All the operations I can do, but then it is basically reducing. This is called folding or reduction or whatever. So I'll do like this. This is the answer, right? So what we have seen, let us recap entire thing. Lambda. Lambda is an unnamed function, an anonymous function. We tend to use lambda when you want to have a function which will be doing its task on the fly. There is no need to save it. Okay. What is map? Map is a function which can take iterables and treat them one by one and create an iterator. Filter also does same thing, but the thing is filter has the capacity to filter the data. Whichever data is not evaluating to true, please filter them out. Okay. And reduce is what? It is a folding mechanism, a reduction mechanism, the way we have seen over here, right? So it will give you single value. So filter and map gives you iterator, reduce gives you single value, and lambda is unnamed function. So these are used extensively in data science projects. Okay. Map, filter, reduce, these are part of functional programming, right? Why functional programming? In functional programming, see, there is a function called map, and then it is taking another function as an argument, and this particular technique is used in functional programming extensively, and that is precisely why it is called functional programming. So this is the basically concept of functional programming. That's all. Thank you for watching, and I will see you in the upcoming video.